This is the question. First one. This is the first part that you'll have to do, and I would say this is extremely important to your success moving forward. You can understand, if you do choose to take calculus again, or if you take a test. But the formal definition, the derivative, finding an equation for a line tangent to y equals 2x minus x squared at x equals 2. So, do you remember what the formal definition of the derivative is? That is the formal definition of the derivative. Now, here's kind of a thought to you, okay? In order to write an equation for a line, what two things do you need? Slope and a point on the line. And so in this situation, what does the formal definition represent? It represents the slope. Because remember, the whole idea is the derivative is instead of finding the slope at 2 points, between 2 points, I'm finding the slope at 1 point. Because the distance between the 2 points is moving towards 0. That's the beauty of this. That's what you remember. That's what we thought was so amazing. And that's where we move forward. So I need two things. I need slope, and I need a point on the line. One of these is easy to find right now. Do you know what the point on the line is going to be? 2 is your x value. 0. How did you get 0? You plugged it into right here. Now, whatever you have to do to help yourself keep track of these notes, again, these are the problems that you'll have to perform. So 0 is that point. So then I have the limit is f of x plus h minus f of x all over h. As h approaches 0, what do I do now? I plug x plus h into it. Limit as h approaches 0, I plug x plus h in. So 2 times x plus h minus x plus h, that quantity, squared, all over h. Now, what? Hold on. I'm sorry. I'm sorry. I did a bad job here. Yes, I did. F of x plus h is 2 times x plus h minus x plus h quantity squared. Now I have to subtract off my function minus my function, which is 2x minus x squared. I'm sorry, I did not write the function subtracted earlier. Now, can you remember what should happen as we work this through? We should have most of the we should have the h cancel out of the denominator. And then, we might have to take one out. We'll see what comes up here. So as I work this out, from this point, it's now just algebra. Limit as h approaches 0 of 2x plus 2h minus x squared minus 2xh minus h squared minus 2x plus x squared over h. Ricey boy, what do you see? 2x's cancel. X squareds cancel. Everything that is left has an h. So what can I do? Divide an h out. So you're left with the limit as h approaches 0 of 2 minus 2x minus h. Stop. Look. 2x minus x squared. What's the derivative of that? 2 minus 2x, right? So that's what we should come up with in the end. Can we now put 0 in for h? And you get 2 minus 2x. Yeah? Yeah. But, right. Oh, well, thank you. I did something right. Okay, thank you. So we have 2 minus 2x. What's then the slope? How do I find the slope? Plug it in. 2 minus 2 times 2. And we get -2. Now we write an equation for the line. What? We won't use the A. We won't use the A. Don't worry about that. Yep. We solve, we get b is equal to 4. My final equation is y equals -2x plus 4. Now, you guys, that was a basic polynomial one. There were other ones that involved radicals. There are other ones that involved complex fractions. Would you like to try a radical one? Just a basic radical problem. You try this one, and then we'll move on to the next part. We'll just use the square root of x. Okay. And we will say at x equals 4. See if you can work it out. I'll pause the video. Okay, so this is the example, and so you can see that you multiply by the conjugate, and what's going to happen is it's going to open up the roots on top so that your x's what? Cancel, and your h's cancel, leaving you with what on the top? 1. So we have the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. May I now plug in 0 for h? How can I plug in 0 for h? H is in the denominator. It doesn't give you 0 in the denominator, so it's still okay. So we get 1 over 2 roots of x. And so as you look at the problem, you can see that you have your 2 square roots added together because you have 1 over the square root of x plus square root of x. Okay, boys? I do, but I'm focused on calculus. So, what's the slope going to be? 1/4. What's the point on the line? 4/2. You could go from there, can't you? I'm not going to do an example like the next one, but what if we had complex fractions? What if we had x over x plus 1? Really quick, I'm not going to do this whole thing all the way out, but if you have x over x plus 1, remember, we have x plus h over x plus h plus 1 minus x over x plus 1 all over h. You have to find common denominators in the top. It's a little bit of algebra. Let's move on to shortcuts. Section 2. Product. Quotient. Chain. This should be very familiar. My guess is this is going to come back to you right away. Given f of x is equal to 2x plus 1 over x minus 1, find f prime of x. Can you do it? Remember the quotient rule as everybody looks backwards. Give it a shot. Give it a shot. Is that what you got? So, you guys, to save on time, I would rather not go this far. But if I asked you then to find the slope at a given point, what would be the slope at say 4? You just plug it in, right? Okay. So from there, we could continue to go into the same stuff that we just did. You could write an equation for a line tangent. You could do all sorts of stuff. So, boys, that is the product, or that is an example of the quotient rule. I'll give you a basic example of a product rule, or of a chain rule, and then we're going to do the product rule. Product rule is just so easy by itself. Generally, the product rule is used in connection with the chain rule. So let me give you a chain rule problem, see what you can do there. What if f of x is equal to sine of 4x squared plus 1, and you want to find f prime of x? Can you do that? Somebody that does this, I did a graphic organizer for you. What is the first thing that you guys chose to do in this problem? What'd you set up? The box. Okay. F of u, u of x. F prime of u, u prime of x. So that visual is generally in people's minds. F of u is sine of u. U of x is 4x squared plus 1. F prime of u is cosine of u. U prime of x is equal to 8x. We take this, we put it back in for u, we multiply those together. 8x times the cosine of 4x squared plus 1. Yes? It's so easy now. You remember how much we had to practice some of this stuff. And so the review for you guys actually goes pretty well. You try the product and the chain together. Try this one. F of x is 3x secant of 4x. So my hint to you is yes, this involves the product and the chain. Derivative of secant is secant tan. Derivative of tan is secant squared. Derivative of cotangent is negative cosecant squared. Derivative of cosecant is negative cosecant cotangent. Derivative of secant is secant tan. Very good, sir. I'm going to be watching you on Friday night. I got to sell tickets, so my first play at Albert Lee. Yep, first play. Nope. Do I have that right? There's your derivative. Colleen? Question? Okay, so, yeah. Yeah, exactly. No. Yep. So this is a product rule, right? So the derivative, I take the derivative of the first part. Derivative of 3x is 3. So I've got that. Times the second part left alone, which is that, right? So far we've done f prime times g plus g prime times f. So we've done those first two, right? Plus, now f left alone is 3x, right? So 12x, so I have this 3x here, times g prime, which is the derivative of secant of 4x. The derivative of secant of 4x is 4 secant of 4x tangent of 4x, using the chain rule. So I take that 4 times the 3x to get the 12x, secant of 4x tangent of 4x. Better? Okay. All right, so that takes us, we have some other things to do in Chapter 3, implicit differentiation. We'll see what you remember here. So this is kind of your third topic, implicit. This is an important one because this is the one you'll forget. Yep. So we're going to use here find the equation for the line tangent to x to the third plus y to the third equals 6xy at the point 3, 3. Yep, good problem. Excellent problem, as a matter of fact. Okay. We're taking the derivative of x with respect to y. Okay. So let's keep that in mind. Our first goal is to find the derivative of this function. You have a couple options. You can either use implicit differentiation, or you can solve explicitly for y. Note that everything we've done before has been, say, y equals 2x plus 1. Okay? What is the derivative of y? 1 times y prime. What's the derivative of 2x? 2. Derivative of 1, 0. So you see what happens when you take the derivative of the y, you get the y prime. So we have to remember that. So we start to take the derivative of this. What is the derivative of x to the third? 3x squared. What is the derivative of y to the third? I can see I was very proud of how you guys handled this unit. I student taught this at Armstrong Plymouth, and they hated life during this time, and you guys did pretty well. So I do remember this. And equals, now we'll see who really has their act together now. Product rule. Oh, whoa! And the anger comes out. Okay, the anger is there. It's there. All right. So we need the product rule here. You have x times y. Those are two completely different changing pieces. They change at completely different rates. We have to use the product rule. So I'm going to choose to group 6x together and leave the y by itself. So within the product rule, I take the derivative of the first part, which is 6 times the second part left alone, plus the first part left alone times the derivative of y, which is 1y prime. No. Now what? What am I trying to find? I gotta know y prime. I gotta know y prime, so I get the y primes on one side and everything else on the other side. So I'm gonna save this 3y squared y prime over here. And I'm gonna subtract that 6x y prime over to the other side. I'm gonna move the 6y minus the 3x squared. Thank you. All right. Am I on the right? Okay, good. I'm on the. It's good to know I'm on the right track. Thank you. Thank you. So, now what? Factor out a y prime, GCF, baby. Times what? You want to divide it now? Okay. I'm going to take a 3 out of the top when I divide it as well. Yeah. What's the goal of the problem? Find an equation for line tangent. What do I need to have in order to do that? Slope and a point on the line. We have 3, 3. How do I find the slope? Plug it in. And what's new about this is that, guys, is that, yes, y prime is the slope, but that we are not just plugging a value in for x, we're also plugging a value in for y. So in this situation, y prime will be 2 times 3, which is 6, minus 3 squared, which is 9, divided by 9 minus 6, or negative 1. That is your slope. Remember how long it took us to first try to do this stuff. So now it's just simply we write an equation for a line. Y equals mx plus b. So 3 equals negative 3 plus b. 6 is equal to b. Negative 1 times 3. So I did m is negative 1, x is 3, so negative 3. So we got y equals negative x plus 6. That would be the equation for the line tangent. True or false? I could just plug that in my calculator and graph and see its tangent. False. It's not a function. This is, you're trying to plug in x, y together. This is not a function if you were to graph it. A similar problem would be, let's say we were just to look at a circle, okay? Maybe you want to try that one. You want to try one on your own? Oh, that's an easy one. Try it, okay? Equation for line tangent. Whoop, I'm 4-3. Oh, sorry. Sure, we'll do 0, 3. There you go. And if you already know it, don't just work the problem out. I just picked something that's going to work. Okay. Same type of problem. That should be your equation. Y equals 3. I know, that's what I said. That's what I said. Yep, here we go. 2x plus 2y times y prime is equal to 0. You take the derivative, that's what you get. Okay, we must solve for y prime. So if we solve for y prime, what we get here is 2y times y prime is equal to negative 2x. Divide both sides by 2y. We get y prime is equal to negative xy. So the slope is negative xy. What do you do from here? You plug in your x, you plug in your y. As you can see, your x is 0, your y is 3. So your slope is 0. Your point on your line, 0, 3. As you can see, that is your y-intercept as well. You have a 0 slope, you have a y-intercept of 3. Isn't that a nice problem? Chelsea's smiling. All right. All right, let's try one more. We'll call it a day. Area of a circle is increasing at a rate of 4 pi centimeters squared per minute. What rate is the radius increasing when the area is 100 pi centimeters squared? 100 pi centimeters squared. This, you guys, this looks like a bad problem. It's not a bad problem. I like to divide this problem up into 4 sections. In the first box, I like to draw a picture of what's happening. I have a circle, and the area is increasing. That's what's happening. We have a radius. We obviously have area. Let's boys, let's list our knowns and maybe even our unknowns. Do we know the current area? What is it? 100 pi. Do we know A prime? Yep, 4 pi. So I have area that's changing. I also have radius that's changing. Do we know the current radius? Nope. But we sure could figure it out, couldn't we? If the current area is 100 pi, what is the current radius? 10. Do we know R prime? That is the question. And in order to relate these two together, I am going to write an equation, namely that area is equal to pi times r squared. We are looking for the derivative of the radius with respect to time. So, what is the derivative of A? A prime. What is the derivative of pi r squared? 2 pi r r prime. Remember, we just did implicit differentiation because we are taking the derivative with respect to t. Therefore, we have to attach an a prime or r prime to everything. Do we know a prime? What is it? 4 pi equals 2 pi times 10 times r prime, or 4 pi is equal to 20 pi times r prime. Divide both sides by 20 pi. 1 over 5 is equal to r prime. 1 over 5 what? Centimeters per minute. We'll start with the related rates problem tomorrow. You guys, I'll be honest, I think that after this, the rest of the stuff that we review, you're going to think is pretty easy as I look at the rest of it. We do have to talk about concavity, increasing, decreasing, optimization, but I think it's all going to be much more familiar to you than this is. Good job today.